Most welcome to the platform of Inside Chemistry, guys. So, we are having another lecture of reaction mechanism, that is, elimination reaction. It is the most important concept of reaction mechanism, as we had discussed SN1 and SN2 reaction in our previous videos and some major concept as well. So, go to our playlist and watch that videos, and let's come towards our today's topic, that is elimination reaction. We'll discuss the definition, the examples, and as well as the general features of the elimination reaction. So come towards the definition, that what is elimination reaction. An elimination reaction is a type of organic reaction in which two atoms or group of atoms removed from a molecule without their being replaced by another atom, which means simply that no any major molecule is needed to remove or eliminate hydrogen and a leaving group from the single bonded alpha and beta carbon. For example, here you can see the leaving group and a proton is removed while making a double bonded alkene here, and hydrogen and leaving group is formed. Hence, this is the example of elimination reaction. And also concentrate that what changes are happened here. So let's come towards the general features of elimination reaction. It is the most general, basic general feature that involves the loss of element from the starting material to form a new pi bond in the product. You know that a new pi bond is formed, and this is the general feature of the elimination reaction, that a single bond is converted into double bonded hydrocarbon. That is the main and most basic general feature of elimination reaction. The single bonded carbon is converted into double bonded hydrocarbon. You can see in example as well that a new pi bond is formed. An alkyl undergoes elimination reaction with Bronsted-Lowry bases. The elements of the HX are lost and alkene is formed. Now, do you know about the classification of elimination reaction? And this is all about the concept of classifying the elimination reaction, how we can classify the elimination reactions. And this is all about the concept of alpha and beta carbon also. An elimination reaction, the alpha carbon is that carbon from which the leaving group is leave, and the beta carbon is said to be that carbon from which hydrogen is leave. This is all about the alpha and beta carbon, and such type of elimination reaction is called 1,2 or alpha beta, or simply it is called beta elimination. So this is one of the classification of elimination reaction. And let's come towards the second point, in which it is said that among the most familiar example, a base catalyzed elimination of hydrogen halides from an alkyl halides to corresponding alkene. For example, propyl bromide gives propene in the presence of alcoholic alkali. This is the example we'll discuss further. And another example is alcohol are dehydrated in the presence of acid to give alkenes. For example, propane 2-ol gives propene when heated with dilute mineral acid. This is another example that alcohol is converted into alkene, and in the presence of acid, that may be acid with low pH or strong acid. And this is the first example in which alkyl halide H with H and Br is converted into alkene by the loss of the leaving groups here, and in the presence of alcoholic alkali. In this step, the first example is saying that the most familiar example of catalyzed elimination of hydrogen halide from the alkyl halide to the corresponding alkene propyne bromide gives the propene in the presence of alcoholic alkali. Hence here catalyst is the alcoholic alkali. You can see the first step that alcohol in the presence of alcoholic alkali, the alkyl halide is converted into the alkali, the alkene. And in the second step is about the alcohols. Alcohol is converted into alkene. Let's see the second step in which alcohol is converted into alkene in the presence of acid. The acid may be HCl or any strong acid with dilute H2SO4. This is all about the second example. The HCl is used as catalyst to convert the alcohol into alkene. Hence, this is the second example of elimination reaction. Now, these are the major types of elimination reaction on the basis of deprotonation and the leaving group. If you look at the first step, in which if deprotonation is first, then leaving group in second. This is called E1CB elimination. And what is E2 elimination? Look at the second step. Here the deprotonation and the loss of leaving group is in simultaneous way. And if these are in simultaneous way, then it is called E2 elimination. And look at the last step in which leaving group is first and then deprotonation is second. This is called E1 elimination, in which leaving group is leave first, then deprotonation. This is called E1 elimination. And these are the major types of the elimination reaction. And this is dehydrohalogenation. Dehydro means removal of hydrogen, and halogenation, dehalogenation is the removal of halogen. And halogen atoms, you know that chlorine, fluorine, bromine, and iodine, and these are the halogens. And if these atoms removed along with hydrogen atom, then this is called dehydrohalogenation. This is happen in elimination reaction, in which they are attached to alpha and beta carbon, one bonded alpha and beta carbon, and when these atoms are leave, then double bonded alkene is formed, and hydrogen and halogen atom is leave from here. And you can see that HB is formed and H is also act as a leaving group. Hence, this is all about elimination reaction and the concepts of elimination reaction. These are the common bases of dehydrohalogenations, which we are using to dehydrohalogenate the alpha and beta carbons in elimination reaction. The most common bases used in elimination reaction are negatively charged oxygen compounds such as HO- and its alkyl derivatives RO- called alkoxides. And the rest of all, you can pause the video and you can write the names, and sodium hydroxide, potassium hydroxide, and rest of all. These are the drying products of dehydrohalogenation. First of all, you have to find out alpha carbon, which is alpha carbon. It is also you need to also know that it is sp3 hybridized carbon bonded to the leaving group. Identify all beta carbons with H atoms. Okay, the carbons which are connected to the H atoms, these are the beta carbons. Remove the elements H and X and form pi bond. This is all about the elimination reaction. Thanks all of you.